Hello everyone, this is Mahima here to explain my fourth experiment in Linux and Unix lab to perform base conversions. Base conversions is converting the number having a base into another number having a different base. So in this I'll be performing four base conversions. So my first one is binary to decimal conversion. So this is my code. First of all, I have prompted the user to enter a binary number, and then I check till the binary number is not equal to 0, then my loop runs. So here I have first of all equated the binary number to another variable. I have initially taken decimal as 0 and the power value becomes 1. Inside that I have another while loop checking the same condition, and this time I am performing these operations. I need the expression value of the binary number and a modulus of 10. This is in order to get the unit digit alone, and as we all know, in order to convert one base value into decimal, we take up each and every unit digit and multiply it based on the powers of the previous conversion that we want to do. Like in this case I have binary, so in every time I'll be multiplying the unit number or the unit digit with powers of 2 starting with 2 power of 0. So every time I get my digit, and then over here I keep changing my decimal value as decimal plus the remainder that I get from the previous expression into the power. Initially power is 1. After that, I keep changing my power value as power into 2 each time. And after that, my binary value also changes as binary, that is the value divided by 10. So in this case, my unit digit alone can be omitted. Now, when I execute my code, let me enter a binary number, we get the output as decimal number. Now for my second one, I'm supposed to convert decimal to binary. So every time we want to convert a decimal into binary, we perform the factorization method, and each time we get a reminder. Based on the reminder value, when we write the values from bottom to top, then we get the required binary number. And since we are converting decimal to binary, we divide that number every time by 2, as I have done over here. So let me show my code. So over here I have first prompted for the decimal number, and then I have taken a new variable initializing it to 0. Now till my the input number is not equal to 0, then first of all I divide it by 2 as we saw in the algorithm, and then we get the unit digit, and then after that I divide it by 2, and then I put a new value inside bin, that is the value of r and bin. So at the end we can see that I echo my bin value. So let me execute my code. So let me enter my decimal value. Let us check using this one. When I give 12, I get my output as 1100. Now for the next one, we are supposed to convert hexadecimal to decimal, and as we saw in the previous one, every time in order to convert to a decimal, we are supposed to multiply the unit digit by the respective conversion of which we are beginning with. So in this case, since it is hexadecimal, we will be multiplying the unit digit with powers of 16, starting with 16 power 0. So let me show my input code. This is my input code. So first of all I prompt for a hexadecimal number, and as we did in the before programs, I check if my hexadecimal is not equal to 0. Till then I initialize the value of hexa into a new variable. Decimal would be 0, power would be 1. Then another while loop, we have the same condition, and then I calculate my reminder value every time modulating it by 10, and then I calculate my decimal value, then I do with my power, and here is the difference where I have multiplied the power by 16 every time. Then if we execute our code, Let me enter a hexadecimal number, for example 20, 26. I get my output as decimal number equal to 38. Now the last conversion we are supposed to do is binary to hexadecimal. So in general we all convert it by taking up 4 digits from the right and then writing the equivalent hexadecimal, but in this we have two values called as the I base and O base. When we equate O base equal to 16 and the I base equal to 2 followed by the number which we want to convert, then we can see that we can acquire the required output. Let me show the code to you once. Over here, as you can see, I have first of all taken my O base as 16, I base as 2, and then this is the input number that I have prompted from my user, followed by BC, that stands for basic calculator. So just by giving this one statement, I can convert my binary to a hexadecimal number. So let me show you the output. So over here, first of all, it's prompting me to enter a binary number. Let me enter this. I get my output as C, as C equates to 12. So that's all for my experiment. Thank you for watching.